Welcome back to RS Academy. This is Ravi Shankar. We are discussing carbon and its compounds. In last videos, I have given clear picture regarding to formation of covalent bond between similar atoms and dissimilar atoms as well. Please go through that videos. In this video, I would like to give clear picture of two important questions of carbon, that is, why does carbon always form covalent bond, and second one will be, so nowadays millions of carbon compounds are available in the nature, what is the reason behind that. So in this video I would like to give answers and with wonderful explanation regarding to these two questions. Get ready students, let us have a talk of first question, that is, why does carbon always form covalent bond? Why does carbon always always form covalent bond? Why does carbon always form covalent bond? Why does carbon always form covalent bond? Listen carefully. Carbon atomic number 6, that mass number 12. That means each carbon consists of 6 electrons, 6 protons and 6 neutrons. 6 neutrons. What is the electronic configuration of carbon? Yes, right, good. 1s2, 2s2, 2p2. How many shells are there in the carbon atom? Each carbon atom consists of two shells, first and second shell. Let me draw electronic structure of carbon. So let us assume this is a carbon nucleus of carbon, nucleus of carbon. It has two shells. This is the first shell, and this one is the second shell. Right? How many electrons in first shell? 2 electrons. In second shell, 4 electrons. Second shell, 4 electrons. This is a electronic structure of carbon. Right? Each carbon atom consists of 6 electrons, 6 protons and 6 neutrons. The protons and neutrons located center of the atom is called nucleus. Electrons are revolving around the nucleus in a fixed circular path. These are called shells or orbits. Right. I said each and every element wants to attain nearest noble gas configuration by the gain or loss of electrons. In case of covalent bond, I have done that. Please go through that video. Then what about carbon? Why does carbon always form covalent bond? Carbon is a non-metal like chlorine, fluorine, oxygen, sulfur, like this. Selenium, carbon, iodine, phosphorus, sulfur, bromine, chlorine, fluorine, oxygen, nitrogen, hydrogen. These all are non-metals. These non-metals are ready to produce ionic bond and ready to produce or form covalent bond. They are ready to form ionic bond and covalent bond as well. But then what about carbon? Carbon only forms covalent bond. Now listen to me here. Chlorine combined with sodium gives sodium chloride is ionic bond. Here chlorine involving in the ionic bond, and chlorine react with hydrogen gives HCl. Here chlorine involving formation of covalent bond. That means most of the non-metals have tendency to give covalent bond with other non-metals and have tendency to give ionic bond with other metals. But carbon always gives only covalent bond. This is a very important question. Why does carbon always form covalent bond. So let us find out the answer the given question. Right. Let me write one more information here. Each carbon has 6 electrons. 1, 2, 3, 4, 5, 6. And 6 protons as well. 1, 2, 3, 4, 5, 6. Number of electrons are equal to number of protons, so that's why atom is electrically neutral. Right. Carbon atomic number 6. It has two options. Either attainment of helium or attainment of neon. Neon atomic number 10, whereas helium atomic number 2. So let us discuss about attainment of helium configuration. Later let us have a talk neon configuration. First one, in case number 1. If the carbon wants to attain helium configuration, it should lose 4 electrons in order to produce C4 plus cation. C4 plus cation. If you remove electrons, if these 4 electrons, then only 2 electrons remains in atom of carbon, so it leads to attainment of helium configuration. Listen carefully. So if carbon wants to attain helium configuration, it should lose 4 electrons. It should lose 4 electrons. If you want to remove electrons from valence shell of any element, atom of any element, we need to provide energy because of a strong force of attraction is existed between oppositely charged particles. To remove electron from the valence shell of an atom, we need to provide the energy which is sufficient to overcome the existed electrostatic force of attraction. So, if you want to remove electron, we need to provide energy from the outside. Let us assume I am giving energy from outside to remove this electron. I will show here. Listen carefully. I provide energy, I remove this electron. Let us assume. What will happen? Here 6 protons and 5 electrons. The proton density increases and whereas electron density decreases, then the 6 protons strongly attract remaining 5 electrons. Now, let us use energy 1. I am giving to energy and to remove second electron. So for every turn, the providing energy amount increases. So that's why it's very difficult to remove electrons from the valence shell of carbon. So due to increment of proton density, if you remove this electron and number of electrons are 4 and number of protons are 6, so that's why 6 protons strongly attract remaining 4 electrons. So by every turn removing of electrons difficult due to strong force of attraction and increment of proton density. So that's why this path was rejected by the carbon. Listen carefully. The option number 1, it has chance to attain helium configuration, but here removing of electrons one by one from the carbon somewhat difficult. So that's why this path was rejected by the carbon. Next path number 2 or case number 2. If the carbon wants to attain neon configuration, it should gain 4 electrons. It should gain 4 electrons. Should gain 4 electrons. Right? Are you following, my dears? Okay, good. It should gain 4 electrons. its carbon is ready to accept electrons from others, but protons are raising their voice because of, so don't accept electron from outside because of happy with we are happy with 6 electrons because of each proton attracts each electrons. So 6 protons saying that we are happy with electrons, but we are unable to hold excess electrons. So don't accept electrons, don't gain electrons from others. So that's why this part also rejected by the carbon. To attain to attain neon configuration, it should gain 4 electrons from others. But protons present in the nucleus raising their voice. So please don't accept electrons from others because of we are unable to hold the excess electrons. So if it is gain electron, it forms C4 minus ion. So this case number 1 also rejected and case number 2 rejected. So instead of gaining or losing electrons, carbon has tendency to share electrons. By sharing electron, carbon attains neon configuration. Is it clear? Why does carbon always form covalent bond? So it has two options, either attainment of helium configuration or neon configuration. If it is want to attain helium configuration, it should lose electrons. So removal of electrons from the valence shell of carbon is somewhat difficult. So that's why it was rejected by the carbon. Next one, if it is wants to attain neon configuration, it should gain 4 electrons from others. So here protons present in the nucleus of carbon raising their voice, so we are unable to hold excess electrons, so don't accept or gain electrons from the others. So that's why this one also rejected by the carbon. So instead of gaining or losing electrons, carbon has tendency to sharing electrons from uh, two neighboring sharing of electrons to neighboring atoms. So sharing of electrons is called covalent bond. So this is the reason behind the carbon always forming covalent bond. Is it clear? Good. See around us. Right. So let us answer this given question. Let me read out. What are the two properties of carbon? What are the two properties of carbon which led to the whose number of carbon compounds we see around us? Get ready. So nowadays millions of carbon compounds we can see around us in the form of proteins, carbohydrates, starch, glucose, sugar. These all are carbon compounds. Petrol, diesel, kerosene. So plastics. So most of the 99% of compounds around us is made up of carbon. So what is the reason behind that? So the reason being versatile nature and tetravalence of carbon. What's the reason behind that? First one is versatile nature of carbon. Please write down versatile nature of carbon. Versatile nature of versatile nature of carbon. Versatile nature of carbon. Versatile nature of carbon. Versatile nature means unique properties of carbon. Carbon has two unique properties. One is tetravalency. Tetravalency. Tetravalency means carbon gives 4 bonds with neighboring. It gives 4 bonds with neighboring. Because of what is the carbon valency and valence electrons? Carbon atomic number 6, electronic configuration 1s2, 2s2, 2p2. It has 4 valency electrons. If the element has 4 or less than 4 valence electrons, it is equal to its valency. That means carbon valency also 4. Valency also 4. That means carbon is ready to give 4 bonds with neighboring. Carbon is ready to give 4 bonds with neighboring by sharing its 4 valency electrons. Example, formation of methane. Listen carefully. So carbon has 4 valence electrons. It combined with 4 hydrogen atoms. These 2 electrons are belongs to hydrogen. These 2 are belongs to hydrogen atom. And these all electrons are belongs to carbon. So you will get C bond H bond H bond H. That means carbon always gives. If you take any compound of carbon, it's ready to give only 4 bonds with neighboring. So because carbon is tetravalent in nature. So this is one of the reason behind existence of huge number of carbon compounds in the environment. So first one is tetravalent nature. Tetravalent nature. Copy. Next, second property will be catenation property. Catenation property. Catenation property. Catenation property means self combination. Self combination. Self combination. That means carbon has capability to combine itself with other carbon atoms to form longest possible chain, like this. Longest possible chain without breaking. This property is called catenation property. Catenation property. So nowadays millions of carbon compounds are available. The reason being is versatile nature. Versatile means unique properties. Carbon has 2 unique properties. One is tetravalent nature. Second one is catenation property. So due to these 2 properties, so millions of carbon compounds are available in the nature. So one is tetravalency and second one is catenation. These 2 properties collectively called as versatile nature of carbon. Versatile nature of carbon. Is there any element other than carbon exhibiting these properties? Yes, silicon. Silicon also exhibits versatile nature like carbon, but not more than 8 atoms. Let me show that. Silicon also capability to form 4 bonds with neighboring and self combination as well. 1, 2, 3, 4, 5, 6, 7. Up to 8 or 7 atoms it's possible. Up to 8 atoms it's possible. Up to 8 atoms it's possible. Because of the bond between carbon and carbon, is very strong when compared to bond between silicon and silicon. So because the size of the carbon atom is very small when compared to silicon. Size decreases, the strength of the covalent bond increases. So due to small size, carbon forms strongest covalent bonds between carbon and carbon. Whereas silicon, the big bonds, it's up to combined up to 8 atoms only, it's possible. So this is also one of the important question in the examination. So name the element other than carbon which exhibit tetravalence and catenation. That is silicon. It's up to only 8 atoms. Okay, is it clear to you?